Working on collision detection is always going to be a challenging part of any type of game or interactive programming. So right now, you'll notice how the boxes, the moment they overlap, the background turns red. When they're not overlapped, the background isn't red. And this is rectangle-based collision. It's an additional method to learn and understand. We looked at circle-based collision previously. Now, I have taken the liberty of drawing rectangles in each one of my sprite classes here. So the unicorn draws the blue one, the eyeball draws the green one, so that we can see where these boxes are and see when that overlap occurs and when that intersection takes place inside my code. It says, hey, if an intersect has occurred between my enemy and my sprite, then it just sets red to the fill color and it draws a rectangle over the stage in red. So that's why the world turns red. But we could just as easily play a sound. We could subtract a score. We could take away from a health meter. We could make any number of different things happen. Maybe it's a one touch, one kill kind of experience. So if the intersect does actually happen, it changes the game state. So any of those different things that we'll look at are going to come to pass. So there's an intersect function. We used intersect before, but this is now a new version of it. And this version is now expecting my enemy and my sprite. So then if I look at my intersect function, we'll see that it says all kinds of ugliness. So in this, it's not the prettiest looking thing, but it gets the job done. And that's the important thing. Now there's a lot of stuff listed in here and going on here because we're having to keep track of when these two objects are overlapping based on where their centers are and where the boxes are. So we're going to simplify it first and just think about what is the kind of the conditional that needs to be written for having one box intersecting another box when we know 4 pieces of information for each box. We know it's x, we know it's y, we know it's width, and we know it's height. Once we have that information, then it becomes possible to start to construct and figure out, well, how do we test for that? How do we look for that experience? So I'm just going to jump over to Photoshop where I have an empty canvas or a whiteboard so that I can sketch here. So if I have one box, and if I have another box, right now we can see these boxes are not overlapping. So I have 2 boxes, and I'll have this be enemy and this be sprite to match what we have in the current game code right now. So I have my enemy and my sprite, and we know each box is x and y, and we also know their widths and their heights. So we have those 4 pieces of information for each object. So x, y, width, height. And because we know that information, it's going to just be a matter of figuring out at what can we look at and when are they overlapping. Now if I look at my enemy here, if we see from the enemy's x and its width, what we really care about is when the sprite has crossed that line. Because on that x-axis, so keeping in mind we have our x-axis and the y-axis. So, and truth be told, every time I don't just copy paste my code for doing this between projects, I actually draw out the boxes and sketch this out looking at, okay, so when this point versus this point, I actually draw out the boxes to reinvent the algorithm for it, because just to think about it without the visual aids, I find to be a challenging activity. So what we're concerned about is at this line here, when has my sprite box crossed it? Because when it's moved past that, on the x-axis, these two objects are overlapping. But this box and this box on the x-axis, they're not overlapping yet. So we're trying to find out when have they crossed into each other's horizontal space. And doing this is really going to be, it's a matter of we're checking both horizontal overlaps and vertical overlaps. And we have to check 2 cases for each to figure it out. So we have 2 x and width statements and 2 y and height statements here. So once you get the x and the width down, figuring out what are the possibilities of when the boxes are overlapping, then it's not so bad to figure out. I'm just going to, no, there we go. Start out clean here. So if I, go back to my brush here. So if I have a box, my possibilities are the boxes are not intersecting, or the boxes are intersecting, or the boxes are not intersecting. So if these are all my sprite box, we can see the possibilities within the horizontal space here. Either the sprite is to the left, it's overlapping, or it's clear to the right. So there's those 3 kind of possibilities that we could have on the horizontal or x-axis. That's what we're looking for here. And because we know 4 pieces of information about each one of these boxes, we can then figure out, are they overlapping or not? So what we do is we check this edge, actually. So we check this edge here, the right edge of my enemy, and I compare that to my left edge. So I'm looking for what has happened. Because right here we can see that the left edge of this box here, that's x, and the edge over here is its width. So we can define that as x plus w of my E object. So that now tells me this little point, let's get a different color here, this little point right there in space. So we now know that point, x plus w for my enemy. Now we compare that to the left edge of my sprite. And it's either going to be where the left edge is bigger than that point, they're not intersecting. It's going to be less than that point, which means they could be intersecting. So anytime that left edge is over, there's a possibility they could be intersecting. So what we're going to be doing is checking edge to edge, and then we will have a second statement where I will compare that edge of the box to that edge. So when we move it around, it becomes a little bit clearer. It's like, oh, okay, now we can start to see that distinction. And I now realize that I might start drawing my boxes on separate layers, so then I can actually start dragging them and making it a little bit easier. So the core algorithm that we'll be looking at here is if we take the enemy's x plus the enemy's width, which gets us to here, and we need to find out, is that greater than the sprite's x, this point here? Because if this point is greater, that means it's now past, I like red, it's now past that point, so we know that's happened. So we now know that the box is not floating somewhere in space over here. So we first check for that. Let's get big. So now I'm going to check for the other side. The other possibility is going, okay, well, what about, let's see, where's a good color? I'll grab orange. So the right edge here, how does that edge compare to the left edge of the box? So for that one, we compare the enemy's x. Is the enemy's x going to be less than, and then we're going to be asking about this edge, which is going to be the sprite's x plus the sprite's width. So then that, because the sprite, if this is the sprite, it's x plus its w brings us out to that point there. Brings us over to here. So we're now comparing that edge. So we're now finding out where is that edge in relation to the left edge of my enemy. So we take the enemy's x. Is that less than the sprite's x plus the width of the sprite? So then if both of those situations are true, so it would be the double ampersand. If they're both true, that means they must be overlapping. Because if this one isn't true, and this one is true, well, no, then it's going to be off in space. So we have to first figure out, is it over here, or are they somehow overlapping in space? And we can code that into our project. And once we do it for the x, you can really just take this, copy, paste it, change x's to y, w's to h's, and it works. And so once you figure out, have two objects overlapped on the x-axis, it starts to make a little bit more sense. Now here it is with the intersection with the x's and y's worked out. So we can see when these two boxes overlap, when their left edges intersect, then I'm changing my background color. So we can see when they overlap, the magic is happening. What's important to keep in mind is we're looking for, essentially you're trying to compare, if we say the unicorn is the enemy, we're comparing the unicorn's right edge to the left edge of the eyeball. And then, now they're intersecting, but when they're on this side, now we're comparing, oh, stop chasing me, come on. Comparing the right edge of the eyeball and the left edge of the unicorn. So we're doing that, the nearest edge comparison. That's really what we're figuring out here. So if we compare the x of this rectangle plus its width, this point, and we're comparing it to the x of this. So have those two lines intersected. And as soon as they intersect, you visually see a color change occurring because that's what I programmed into it. And it works for both the left edges, but now we can compare right edge of this box to left edge of this box, because those are really the only kind of cases. It's either the edges, the object is to the left of it, they're overlapping, or it's to the right of it. That's it, plain and simple. Maybe not simple, but plain. So we can see what's going on here. Now, if you remember last class, when we did this, we shifted the artwork over to better control the chasing. Because otherwise, when the unicorn chased the eyeball, not based on the center, but based on a top left coordinate, then it was always trying to locate the eyeball up near its tail instead of the middle of its body. So that's why we shifted the unicorn over and shifted the eyeball over, so they're drawing out of their centers. Right now, these two rectangles are drawing out of the center, in essence, the centers of these objects, because they're drawing at x and at y. And that is why in the code before I modified it here, it had some extra gobbledygook in there. So it had in this minus half of the width, minus half of the height for drawing that rectangle the same as how we drew the sprite. So we shifted the drawing of the artwork over from that x and y coordinate. So it's the same as if we have our artwork here and it has an x and y coordinate, then saying I want to draw the artwork. So we shift the artwork, we move that point off in space here, half of the width, and then we shift it up half of the height being h divided by 2, half of the width being w divided by 2. So we're shifting the drawing or representation of our artwork over by half of its width and half of its height, so that when the other object decides to move over, it doesn't draw it up in the corner here, but instead it does center on center. So that's why we did that last class, and that's why we will be doing it again as well. So inside my objects. Now, you don't need to draw these rectangles in or do any of that because your artwork is already shifted over. But I put the rectangles in because when you're looking for collisions, it's much easier to verify if the collision is working how you want it to work when you can actually see box overlapping with box. When I just see pixels overlapping with pixels, it's not always clear if they're intersecting properly. Because if I just go and turn these rectangles off, and now run my game, when they overlap, it's like, okay. But so I'm on the tail, and now I'm in front of it, so we can see, it's like, well, something weird is going on. It's not based on where we see the artwork versus where this collision's happening. That's not quite right. Yeah, that sucks. That's not working right. So we don't want to go there. And by turning on the rectangles here, so we take away half of the height, so height divided by 2, and take away half of the width, w divided by 2. So if I do that for each of my rectangles and have these rectangles, it's a really useful thing to show this bounding box around my artwork, so when things happen we can see, oh wait, my collision is not occurring. It shouldn't attack, I shouldn't register a hit when I'm well in front of it, which is what it's doing right now. Well, wait, that's not right. So it needs, and it's not entirely apparent because the eyeball is so small to the unicorn. On the vertical axis, it actually works reasonably well because the object isn't that big. But we can see horizontally, it's way off. So that's telling us that our algorithm is going to need a little bit of work. Now, looking back at that algorithm that we're working with for the intersection. So if we compare within this, we can see I take the x plus its width, compare that to the x of the other object, and if the x is less than the other objects, oh yeah, we got a few other things. I forgot to take those off. Whoops. Oh well, we'll get it all fixed in a moment here. But once we get all of that cleared up and squared away, then we are going to have our project set. Oh yeah, that is really, yeah, I shouldn't have, I was supposed to get rid of all of my, now we'll get a more proper response. We can see there we go. So our intersection is not working quite right because it's based on the rectangles being drawn from the top left corner, but that rectangle starts at the middle. So it starts at the middle of each object. So we need to fix the code up here. And the fixing of the code up there means we just have to modify those widths a little bit. So we use half widths and half heights instead of full widths and full heights. So we're just going to have a few modifications to this to use the half width and half height. So we're going based on centers. And then we just need to shift, because if we look here, again recognizing if we're drawing our artwork not at the top left corner, but we're shifting the picture over, that means we need to really start checking from half of the width over and half of the height over as our new normal. So we do that shift by subtracting here. He's, in this case, for y's, they will all be heights. And for x's, it's all going to be for widths. I'll make sure it's -2, not -2.5. And that should be a height. Oh, and that's not an E, that's an S right here on it. And SX, and then E dot X can be minus E dot width divided by 2. All right, let's see. EX minus its width, so let's see, plus, minus, plus, minus, minus, plus, minus, plus. These are all S's, these are all E's, WWHH, WWHH, okay. Now, if you put this on 4 lines, it looks like gobbledygook, except that it's highly repetitive and makes it easy to see. Now, sometimes people will put it all on 1 line like this. And because you do not get penalized for using white space in your coding, I would say this is a nightmare to read, and I would discourage you from doing that. That wouldn't be a good plan. So you really, by keeping it on 4 lines, I really think it makes it easier to read. Now, some people will even put this on a separate line, this on a separate line, so you really just have these 4 things like this. You don't need extra parentheses around it. Sometimes people will want and put extra parens around it like this because they're like, oh, well, between the ampersands keeps it neat and tidy. If you don't have to use extra curlies or parentheses, I wouldn't. It doesn't make it easier to read in this case because now it's the fear is that you're going to forget to put those in. So now I have my half widths, my half heights. My boxes are drawing themselves correctly on my artwork, and we can see when they intersect. And by using the boxes, we can really see clearly when that intersect is happening, and you try it from all 4 directions. And once you've verified that's working, you know you are in good shape to continue forward and make it work in your game. So once you can do this, and you know that based on those boxes that the intersect is working and behaving properly, then at that point I would just go in and comment out all that display information about drawing those rectangles because we don't need it. And now you can just play your game where now we have the Psycho Unicorn that is now chasing my eyeball around on the screen. So we can see how it's working where we have the intersect and we don't.